Hi guys, today I'm just going to go over your study guide. By the end of this lesson, you should be able to review rational number operations and focus on any areas of improvement. It's really important because we usually get focused on the things that we're good at because we like to practice those. But today I want you to notice that if there's anything that you're struggling with or you can't remember, that's what we focus on getting right before the test. So go ahead and go to your binder, turn to the math section, and get out your study guide. So my suggestion is that you watch this video after you have completed the study guide, check your answers with the answer key, and then anything that you need an explanation for, you can skip around in this video to focus on those questions. So I'll go ahead and get started. The study guide is divided up into topics. So each topic has an I can statement. This first one is I can convert a rational number to a decimal. Then off to the side, this is the standard in Kentucky of what I have to teach you. So all Kentucky 7th graders learn the number system. And then how to convert a rational number to a decimal is the first topic. So converting a number to a decimal, you need to remember that line means divide. So the fraction line means divide. And it says determine if the decimal is terminating or repeating. So this is our first lesson on rational numbers, the intro to rational numbers. You might want to turn back to that. I'm going to show you the long division way. And then for the rest of these, you'll just want to check on your calculator. This is how you would set this problem up. You want to think how many times does 8 go into 7? It does not. So you add a decimal, then add your placeholder zeros. You want to add a couple zeros. You want to keep just adding zeros as you go through this. Since you have a decimal in this part under your long division symbol, you want to go ahead and put that decimal up at the top. So if there's a decimal there, there'll be a decimal in your answer. Now you can look at it and think how many times does 8 go into 70? I know that 8 goes into 70 8 times because 8 times 8 is 64. You want to subtract. You have 6. 8 doesn't go into 6, so I'll bring down another placeholder 0. Now think how many times does 8 go into 60? It goes in 7 times evenly because 8 times 7 is 56. I'm left with 4. Bring down another 0. And 8 goes into 40 5 times evenly. So your final answer would be 0.875 or 875 thousandths. The next part of this question says determine if the decimal is terminating or repeating. This is terminating because it comes to an end. There's only zeros after the 5. There's no remainder. If there's a remainder, it might be repeating, but since there's no remainder here, it's just terminating. The last thing I want to remind you is just to make sure that your answer makes sense in context. The number is 7/8. 8/8 is 1. 8/8 is 1 whole. So 7/8 should be close to 1, but not quite. So 0.875 is probably a reasonable estimate, or about 0.8 would be a reasonable estimate for this number. Using that same logic, we'll go ahead and look at number 2. It says convert 9/5 to a decimal. So if you have 9/5, you have more than 5. You have actually almost 2. So you have 1 point something. So we want to go ahead and just think about this as a division problem, where this time we have a 5 on the outside and a 9 on the inside. When you solve that out, you'll end up with the answer 1.8. And again, you can check this with a calculator. 9 divided by 5 equals 1.8. And that will be a terminating decimal because there's nothing that repeats after the 8. Converting 5/6 to a decimal, on the other hand, is going to involve repeating decimals. I know that because whenever I start dividing, I would end up with a 0.8 with a 3, 3, 3, 3, 3. You can also put a line over that 3. So 0.83 repeating. So this is a repeating decimal. And if you want to do this long division style, you would see how many times does 6 go into 5, add your decimal, add your placeholder zeros, and then keep going. And you'll start to realize that you'll get a pattern of 3s. This next section says I can use a number line to find the additive inverse. So you're going to find the additive inverse of these numbers using this number line. Just remember that additive inverse is just another fancy word for zero pair or opposite. It's whatever goes with it to make it a sum of 0. So when we find 7 on the number line, I know that its opposite or its additive inverse would be -7. So -7, I know that they're equal distances apart from 0 on the number line. The same thing goes for -2.5. It's -2.5, so it's between the -2 and the -3. So the positive version of that would be on the other side. So just the opposite. This should be pretty easy. I'm just going to go through and just write the opposite of each one. Each one of these just has an additive inverse of a number that is opposite it on the number line. So 5 and 6 get a little bit harder. It says I can use a number line to represent addition and subtraction of integers. So we're using a number line to represent or model equations. So it gives you the model and you're to come up with the equation. So every time we look at a number line, always starts at 0. We always start at the 0 mark. So we started at the 0, and I can tell that because this is at the end of the arrow, and it goes to -1. So -1 will actually be the first part of our problem. We don't need to put the 0 because we automatically know we start at 0. So I'm going to -1 to begin with. Then just following the arrows, I'm going to the left. And you should be thinking to yourself, going left on the number line means what? Add or subtract? Think about that for a second to yourself. You probably said subtract, and that's fine. We can say subtract. And we subtract 1, 2, 3 to get to -4. So our answer, where it lands at -4, that's what it's going to equal. That's what it's going to get to. So you could have put -1 minus 3 equals -4. We also know that we can write subtraction problems as plus negative. So you can start at -1, and you could write plus a -3. This would be the same thing, and this would model the same way. If you're adding a negative, it means you're going backward, and that would still equal -4. So you could have had either one of these, and that would have been acceptable for this problem. So let's go look at the next one. Like I said, we always start at 0, and we started at 0 and went back to -4. So our very first number should be a -4. That's our starting point. And then I went to the right. So the next arrow, if I'm following this story, goes to the right. If you're thinking of right in math, you're thinking of plus or addition. I went to the right, 1, 2, 3. So I went forward 3 to land at -1. That's where my final answer lands. So you could have written -4 plus 3 equals -1. If you were getting fancy with this, you could have written -4 minus -3, because that's the same thing as plus plus. Look, there's Bob. So that equals -1 as well. So that's why this is the correct answer. But this one is probably what you put, and this is probably the easier way, the first one. This next section is all about zero pairs again. It says I can describe situations in which opposite quantities combine to make 0. Number 7 says complete the following situation to make the quantities combine to make 0. So it gives you a scenario. The temperature during a blizzard is -12 degrees Fahrenheit. Then, and this is where it's your job to think of a situation where we could add something to this to equal 0. So what could have happened for this to end up at a sum of 0? So one possible solution could be that the sun came out and the temperature rose 12 degrees. So either way, if we're down 12, we need to go back up 12. So we're not getting to 24, remember we're getting to 0. So you're looking for something that you can add to a -12 to get back to 0. The only number you can add is 12. So whatever situation you want, but just make sure that your sum ends up being 0. So you have to add a 12. Number 8 gives you a different situation with the same format. You complete the situation to make the quantities combine to make 0. So you have a water level rising to 7 feet above normal. Then what could happen? Well, one thing that could have happened is a drought occurred and the water level dropped 7 feet. So no matter what you do, it needs to drop 7 feet because your sum is going to equal 0. So -7 plus a +7, or 7 plus -7 should always combine to equal 0. So you have to have that 7. And if you have that, then you have the correct answer. Okay, so now we get into these practice problems, and these are just with numbers, no word problems, but all we're going to do is add and subtract rational numbers. We'll start with integers, then get into decimals, then get into fractions. So we're just adding and subtracting right now. So I always like to think of these a few different ways. The first one for number 9, it says you're down 16 and add a down 8. So let's say I'm underwater 16 feet and, it means add, I go down another 8 feet. So I'm getting deeper. I should be farther underwater. So I know my answer is going to be more negative. You can also think about this with the algorithm. Remember the rule for adding negatives. If they have the same sign and they're being added, I just add like normal and then keep the sign. So either way, you should get -24. The next problem says -4 minus 7. So I think a lot of people probably got confused on this one if they thought they saw Bob. This is not Bob. There's no minus negative. It's a -4 minus 7. Minus negative are not next to each other in this one. So you start at -4. That's where you start. And you want to keep the first number, but we don't like to subtract. Remember, we like to add the opposite. So instead of -7, I'm going to add a -7. So we don't like to subtract. We like to keep, change, change. We like to add the opposite. So anytime I see a minus, I always change it to a plus negative. Because now I have -4 plus -7, and I can follow the same rules that I did for number 9. If they're the same sign being added, I'm just going to add like normal and then keep that sign. So 7 plus 4 is 11, and that means that since they're both negative, it'll be a -11. Think about it like I owe Chessie $4, and then I owe her $7 more. Now I owe her $11 in total. Now on number 11, I have a -24 minus a -9, and you do have Bob. So anytime you have a minus negative or a double negative, that really means plus plus, means add. If you look, there's little Bob. So anytime you see Bob, that little happy face, that means you're going to add here. So you keep the -24, and then we take away, remember that means take away the negative. That's the next thing you see. If you take away a negative, you're left with a plus. You could also think about this like you're less negative. If you're less negative, you're more positive. So either way, you're going to end up with negative 24 plus 9. In a real world situation, I might say I owe someone $24, and then they say, nah, I'm going to take away that you owe me 9 of those dollars. If I take away what I'm owing someone, I'm owing them less. So I should be getting more positive. So negative 24 plus 9 is a problem where I have two different signs being added. If they're different signs, a negative and a positive, being added, I'm going to subtract the numbers, which is 11, and then I'm going to give it the sign of the number that has the greatest absolute value. So between 24 and 9, 24 is the bigger number, and it's negative. So it's going to be a negative 11 for this one too. For this next three, we're having addition and subtraction with decimals. So the first step with these is to line them up vertically with the decimal. Now I need to decide if I'm going to add or subtract. I'm adding a negative, and since they're different signs, I'm just going to follow my same rules that I did for integers, the same thing that I did here with these, and I'm going to subtract, and I'm going to keep the sign of the bigger number. So I'm subtracting because they have opposite signs. So 8.5 minus 6.25. I'm just going to go ahead and show you my work on that really quickly. I got 225, and there's my work shown. So now I'm going to look at it and decide which of these numbers is bigger. 850 is bigger than 625, and since the 850 is negative, my answer is going to be negative. So my final answer is a negative 2.25. Let's look at number 13. You have a 10.8 minus negative 6.4. So as you read this, you should have sirens go off in your head when you see a minus negative. Minus negative means plus plus. You see Bob, you see take away a negative, you see a double negative. All those things should be clues that you're going to add. So this is really 10.8 plus 6.4, and then you just add like normal. So line up your numbers vertically, make sure that they're aligned on the decimal, and then we're going to add normal on this one, so I'll just show you my work really quick. And since they were both positive, my answer will stay positive. So my final answer is 17.2, or 17 and 2/10. Let's look at this last example with decimals, number 14. I have a negative 54.26 plus a negative 15.42. So I have two negatives being added together. Since they're the same sign being added, I'm just going to add like normal, and then my answer will be negative since I'm getting more negative. This is like I go to the store and I buy something that costs $54.26, and I buy something that costs $15.42. How much did I spend in total? My answer will be negative, and it'll be increasing as a negative. So as you can see, my first step was to line these numbers up on the decimal vertically, and then I just want to add straight up and down. So I got 69.68. Do not forget to go back and double check your answers on every one of these problems. These are negatives, so my final answer should also be negative. Okay, so let's go on down a little bit. Now for these last three, I'm looking at fractions, and I know that fractions are the uglier ones. There's more steps with these. So I always like to, when I have mixed numbers, make them improper fractions to start with. So I don't ever do anything with mixed numbers. I like them to be improper fractions. So really quickly, you multiply and then you add. So 2 times 1 is 2, plus 1 is 3. You keep the bottom or the denominator, and it's negative. So I always just put the negative onto the top. You put the negative on the top, the bottom, outside, it doesn't matter. I always put it on the top. I'm adding, so I keep that sign plus, and I'm going to do the same thing for this other fraction. 2 times 10 is 20, plus 7 is 27, and then I keep my denominator of 10. So now I've got them both as improper fractions with no mixed numbers. Now I need to find a least common multiple between their denominators. I need the least common denominator. So I need their shoes to match before I can change their outfits, is what I always like to think. So I've got to have these two bottom parts match. So I need to think of what number can they both go into. What's the smallest possible number they can both go into? Well, 10 goes into 10, and I know 2 will go into 10. So I need to get this 3 halves to be out of 10. So I'm going to do that by multiplying by 5. So I multiply the whole thing by 5 over 5, because 2 times 5 equals 10. So I'm just going to show you here. 2 times 5 is 10, so I'm going to change that to a 10. And then 5 times 3 is 15, and the negative times a positive is negative. So I'm going to change the top fraction, or the top part of the fraction, the numerator, to a negative 15. Now that the denominators match, and they're both improper fractions, just lined up like normal, all I do is add the numerator. So negative 15 plus 27. So now I'm looking at this like I would add integers. I have a 27, which is positive, and a negative 15 being added. If they're different signs, I'm going to subtract. 27 minus 15, which is 12. It's positive because there's more positives than negatives. 27 is the bigger number and it's positive. You have a positive 12 and you keep that over 10. So 12 tenths is a final correct answer, but it's not fully simplified. So I want to go ahead and simplify that if I can. I do that by thinking, how many times can I put 10 into 12? I can do one whole time with 2 tenths remaining. And then that's a final answer as well. But I'm still not done because I can simplify one more step. 2 tenths can be simplified or reduced to be 1/5. So your final answer could be 1 1/5. This is like the final answer, and that is like the most correct you could get on this kind of question. It's the most simplified, the most fully reduced. But personally, I would accept this, I would accept this, I would accept this. All three of those are good for me. But try to get this. Okay, so that's a lot of work. Let's look at number 16. Do the same thing. I have a regular 5/8, and then I have a mixed number. So the first step I want to do is to get my mixed number to be an improper fraction. So I'm going to go ahead and go around the world. I always do multiply. 8 times 1 is 8, and then add what's on top. 8 plus 7. So 15 over 8 is your new fraction, and you have 5/8 over here. You have a minus. So I never have a minus. I always change it to a plus negative. Always do that. It's always, always, always important to add the opposite, not to subtract. We don't like subtraction. We like to add the opposite. So now I have on the top 5 minus 15, and on the bottom I have matching denominators. So I can go ahead and do 5 minus 8, 5 plus negative 15. This is the same thing as 15 minus 5, which is 10. And then I know that my answer is going to be negative because the 15 was negative. So there's more negatives, and this is the bigger number, so I'm going to have a negative answer. I'm going to keep the 8 that's on the bottom. I think how many times does 8 go into 10? One whole time with 2/8 remaining. My whole answer was negative, so I'm going to keep the negative on the outside. And then I can simplify this one step further because 2/8 simplifies to be 1/4. So 2/8 would be fine, but 1/4 is the most correct. It's the most fully simplified. So negative 1 1/4 is your final answer. The last question in this section is 1/4 minus 7/8. So both of these are already written as regular fractions. There's no mixed numbers. So all I want to do now is make sure their denominators match. So I need a least common denominator here. 4 goes into 8 two times, so I'm going to multiply 1/4 by 2 over 2. 2/8 is an equivalent fraction for 1/4, and now it matches with the eighths over here with the 7/8. So now I have a 2 minus a 7. I always want to change my minus to a plus negative. When they're opposite signs being added, I'm going to subtract. So I can do 7 minus 2, which is 5. Then I'm going to take the sign of the bigger number. So 7 or 2. 7 is bigger, and it has a negative attached. It'll be negative 5 over 8. So negative 5/8 will be your final answer for number 17. All right, guys, that's it for part 1. As a review, in this first 17 questions of the study guide, we went over fractions to decimal conversions. Remember that line just means divide, so you just divide to get a fraction to a decimal. We learned about opposite zero pairs and additive inverses, and we just reminded ourselves that those are all just ways to make zero. We talked about modeling addition and subtraction on number lines. We finished off by adding and subtracting rational numbers. Those were integers, fractions, and decimals. So in the next section, I'm going to go over the rest of your study guide. It'll be multiplication, division, and strategies. So stay tuned for part 2. Let me know if you have any questions. Bye!